The main topic of this video is the sigmoid function. S of t equals 1 over e to the minus t plus 1. This is a very special function used in multiple engineering applications. The limit as t grows to infinity, to plus infinity of the function is the following. So as t grows to infinity, I have 1 over the limit as t grows to infinity to plus infinity e to the minus t plus 1. So when t grows to plus infinity, the exponential decaying function goes to 0. So I have that this goes asymptotically to 1. So the limit as t grows to plus infinity of s of t goes asymptotically to 1. And the limit of the function s of t as t grows to minus infinity is the following. One over the limit of the denominator which means that as t grows to minus infinity, the exponential goes to infinity, so I have 1 over infinity, and this is equal to 0. So as t grows to infinity, then I go asymptotically to 0. The graph of the function looks like this. And of course, when t is equal to 0, that's a half. So for t equal to 0, let's say 1 is here, a half is in the middle. So when t is equal to 0, the function takes the value of a half, then it goes asymptotically to 1, and then as t grows to minus infinity, this goes asymptotically to 0. Another property that we can study is take the derivative of the function. So you see here it makes a sigma and s, so that is why we call this sigmoid function. Now let's differentiate the function s of t. I will just polish it a little bit. E to the minus t plus 1 the power of minus 1, and I take the derivative of this function. So my derivative of this function s prime is e to the minus t over e to the minus t plus 1 squared, and this is strictly positive for every t belonging to R. We can see that the derivative is positive, so s is a monotonically increasing function for every t belonging to the set of real numbers. Now I can write this as s prime of t equals e to the minus t over e to the minus t plus 1 times e to the minus t plus 1. So s prime of t equals e to the minus t. The denominator is s squared of t. S prime of t over s squared of t equals e to the minus t. So if I take the limit of this function as t grows to infinity, the derivative divided by s squared is the limit of t grows to infinity of the exponentially decaying function, and this goes asymptotically to 0. What other property can we study? S prime of t equals the numerator is e to the minus t over e to the minus t plus 1 and all of it squared. Take the limit of the derivative as t grows to infinity, to plus infinity. I can explicitly calculate this limit. So I can write the limit as t grows to infinity of the numerator over the limit as t grows to plus infinity of the denominator. Let's start with the denominator as t grows to infinity to plus infinity. This term here will go to 0, and I only have 1 in the denominator. And here the numerator as t grows to plus infinity, this will go to 0. So this gives me 0. The derivative goes asymptotically to 0 as t grows to infinity. And if I evaluate the derivative at 0, I have e to the minus 0 over e to the minus 0 plus 1 squared. That's a quarter. I can take, so s prime of t is e to the minus t times e to the minus t plus 1 to the power of minus 2. I can take the second derivative and see what I get. The derivative of the first function here is minus e to the minus t, e to the minus t plus 1 to the power of negative 2. Here I write minus 2 e to the minus t plus 1 minus 3. The derivative of what it is inside, e to the minus t plus 1 derivative times e to the minus t. So the derivative of that is going to be 2 times e to the minus t, e to the minus t, e to the minus t plus 1 to the power of minus 3. Here is going to be e to the minus 2t times this term here. That's the second derivative of the function. This function is very important in various engineering applications, and also there is ongoing research what happens if you if the basis is not e, Euler's constant, but it's another number. There are functions SA of t of the following form. These are called generalized sigmoid functions. And there is research work and literature available.